This Explain Everything is to discuss subtractive library screening, the purpose of which is to find unique gene expression in a particular cell. So let's start just by talking about, well, what do we mean by gene expression? DNA is transcribed into mRNA, which is then translated into protein. So what we're talking about gene expression, okay, here's the genes, they're in the DNA. Okay, how do the genes express themselves? They express them in the form of mRNA and ultimately protein. We discussed in class that all cells in your body have all the same DNA, but they may not have the same mRNA due to different gene expression. Okay, so they express themselves in terms of mRNA. So if we want to look at this, we can determine which cells are expressing particular genes by using subtractive library screening. So let's look at this example. There's two cells, and they may indeed have the exact same DNA. However, they have different gene expression. So for the sake of argument, let's say that cell A expresses itself in the form of mRNA 2, mRNA 3, and mRNA 4. Whereas cell B has mRNA 2. So what we want to do first of all is determine which cell is it that we're trying to determine the unique expression for. So that's the first thing you always have to know. And let's just say this time we want to know cell A. So what cell or what genes are being uniquely expressed in cell A? So the first thing you have to note is that is the cell that you are going to use the reverse transcriptase on and create the cDNA. So we're going to have cDNA 2, 3, and 4. And remember, if you've been asked to illustrate this, that you put reverse transcriptase. That is the enzyme that is creating the complementary DNA. The next step is to pair up the complementary DNA that will hybridize with the mRNA from the other cell. So looking here, we can see that cDNA2 would hybridize with the mRNA2, and then just jot down that that would form a double-stranded molecule. Okay, I'm just going to continue this on the next slide now, because I ran out of room. So the next step is to remove the double and keep the single. So I would like you to at least list that some way, that we are keeping the single, and also list what those singles are. For cell A, it's going to be cDNA3 and cDNA4, and for the cell B, in this case, it's nothing. This is a unique situation. However, I still want you to carry on with the next step of the procedure, which is to remove the RNA, because you wouldn't know that there were no single strands from the cell B. You wouldn't know that experimentally, so you still have to keep up with the steps. You remove the RNA, and then what you're going to be left with is the two complementary DNAs, and looking back, these are the two that would be unique to cell A. So subtractive library screening means you're subtracting out those that are common and going to be left with the cDNAs that are unique to that particular cell. Remembering that those cDNAs represent the mRNAs, and the mRNAs represent the unique gene expression.